So our topic for today is marine meteorology. Okay, so dito muna tayo sa ating mga definition of terms under weather and climate. So Coriolis effect occurs when a mass with rotational movement experiences a force acting perpendicular to direction of motion and to the axis of rotation. So it is called geostrophic force when it is related to Earth's rotational movement. So next is Intertropical Convergence Zone or ITCZ. It is an area that encircles the Earth near the equator where the trades converge, or it is called the doldrums. Then lastly is Stevenson screen. So it is a casing for the wet bulb and dry bulb thermometer made of wood with ventilation holes designed to allow free flow of air past the instrument and at the same time to eliminate the effects of solar and terrestrial radiation. So we have here some illustrations to explain further the given terms we had. So unang-una ay ang Coriolis effect. So sa first image on our left side, lower left, so due to the rotation of the earth, so yung rotation din ng hangin, meron din yang or merong epekto yung rotation ng earth sa rotation ng hangin sa northern and southern hemisphere. So hindi naman ang daloy ng hangin sa earth ay straight line kagaya ng sa hangin ng buga from east to west or west to east. So hindi ganun. So may rotation din yan. So kung mapapansin nyo din dito sa second image natin, sa middle part, so yung mga prevailing westerlies and tropical easterlies. So hindi naman lahat sila sa isang direction lang nagpupunta. So meron pang division. Okay? Then, syempre, dito na pumasok yung ITCZ or yung Intertropical Convergence Zone o tinatawag nating doldrums. So, yan ay 0 degree latitude to 10 degree latitude, north and south. And lastly, we have the Stevenson screen. So, yung Stevenson screen, yung box or yung parang casing na bahay na pinaglalagyan ng ating psychometer or ng ating thermometer na wet and dry bulb. So, kaya yan ay butas-butas para may free-flowing yung air pagpasok dyan. And located ito sa ating bridge wings, sa port and starboard. Next, we have meteorology and climatology. Meteorology is the study of Earth's atmosphere and the changes in temperature and moisture patterns which produce different weather conditions. Next is climatology, is the study of the atmospheric patterns observed over a long period, such as monsoons and seasons, which are experienced by certain area. And lastly, we have climate, is generally considered as the average condition of weather for a period established in particular area. So alam na naman natin yung meteorology ay sa weather conditions, climatology ay sa climate. So yung mga global warming, summer seasons, yan ay sa climatology pasok. And ang ating mga storms, clouds, and temperature, and moisture patterns ay pasok naman sa meteorology. Next, we have two ways of Earth's heat distribution. So first, we have vertical heat distribution. So a continuous heat from the sun enters the Earth's surface causing vertical movements of air called convection. This process creates warm air mass that goes up forming the clouds, precipitation, and thunderstorms. So ito yung vertical heat distribution. So from the illustration naman, makikita natin na ang warm air ay nire-replace ng colder air. So yung warm air na yan, parang evaporation din, precipitation. So yung ini-evaporate or yung vapor na nakukuha niya ay tataas. So yun yung warm air. Then pagkatapos nun, magpo-produce sila ng clouds and maaring mag-cause ng thunderstorms. So kapag ito ay sa dagat naman nangyari, so malimit dyan nagsisimula ang ating low pressure area. And next, we have the horizontal heat distribution. So the Earth as a hemisphere receives different intensities of sunlight in different locations, causing horizontal temperature differences, air pressure difference, and wind circulation differences as it moves from hotter to cold regions. So, syempre, ang ating mundo ay bilog nga, hindi equally ang distribution ng sunlight. So, kaya ang mga higher and lower parts ng Earth ay mas malamig kaysa dito sa atin sa may equator. So, yan yung horizontal heat distribution kasi yung bato ng sunlight, so syempre mas malapit din tayo, mas mainit dito sa atin compared sa ibang regions. So, kagaya sa mga US, sa Japan, sa Australia, New Zealand, so yan. So we have geographical and heat zones. So the classification of different geographical and climatic zones were categorized according to the average temperatures and rainfalls on these areas. Higher and lower latitudes have low angle of incoming sunlight, causing a little heat absorption, while the middle latitudes are receiving direct sunlight. So ito yung mga circles of latitude natin, yung Arctic Circle, Tropic of Cancer, the Equator, Tropic of Capricorn, and the Antarctic Circle. So, syempre, yung Antarctic and Arctic, so sila yung hindi talaga na babatuhan ng direct sunlight, kaya sila yung mas malamig. Kaya nagyayelo dyan kasi hindi talaga sila direct sa sunlight. Which is opposite naman sa atin dito sa equator na tayo ang pinakatutok na tutok sa sunlight. Okay? So, dito naman sa Tropic of Cancer, sa Tropic of Capricorn, so parang balance lang. So, ito yung example din ng horizontal heat distribution. So, next, we have geographical zones. So, the torrid or tropical zones is considered as the hottest area on Earth and categorized by wet and dry seasons. The temperature in the tropics is all year round, warm and humid, generally moist all year with abundant rainfall. Intertropical Convergence Zone or ITCZ is developed around the equator that can bring daily thunderstorms and trade winds from north going in the southwesterly direction and joining the winds from southern hemisphere coming from a northwesterly direction with varying speeds at different times of the year. So, yung mga nararamdaman nating klima or climate dito sa atin sa Pilipinas, so yan yung mga or yan yung pasok dito sa tropical zones kasi nasa tropical zone ang Pilipinas. So malapit din tayo sa equator and sa ITZZ. Kaya sa isang taon natin, so nakakaramdam lang tayo ng 2 seasons, so which is summer and winter. So yan yung warm and humid. So next is the temperate zones. So it's the area with mild generally ranging from warm to cool. It has 4 annual seasons, winter, spring, summer, and autumn or fall occurring in these areas. So syempre yung mga mas matataas ng lugar, so sila na yung nakakaranas ng 4 seasons. So kagaya ng US, Canada, and Japan, sa Korea may kaunting seasons din na ganyan. Dumadaan din sila sa 4 seasons kaso lang minsan meron silang autumn season na napakaikli lamang. So sa New Zealand, so yung mga yan. And lastly, we have the frigate or polar zone. So it's the area that is constantly covered by snow and ice through the year because it is not directly exposed to solar heat or yung direct sunlight. So during nights, temperatures in these zones can fall extremely low. Polar climates tend to be dry because of the descending air is cold and lack of significant moisture that is needed in the formation of clouds and snowfall. So dito sa lugar na ito, kahit yan ay malamig, so nakakadry yan ng balat. So once na na-experience nyo din, mapapunta sa mga may winter countries or winter areas. So once na nag-snow or malamig, lalo na kapag humangin, mararamdaman yung balat nyo nagdadry. No? So, yun ay absence of significant moisture. No? Kaya malimit, nagpuputok-putok yung labi. So, yan. So, an explanation in geographical zones ay ito. So, sun, sun rays dito sa first picture sa left. So, yan yung kung gaano ka lapit or layo yung sun rays or yung bato ng init ng araw sa Earth. So, syempre sa equator, so tayo pinakamalapit. So, sunlight strikes most directly. So, sa ating Arctic and Antarctic, so low angle of incoming sunlight. Okay? So, ito naman sa right side. So, ang ating frigid zone, so syempre yan yung north and south poles. Torrid zone ay ang ating equator or ang ating tropical zones. So, let's proceed to elements of weather and climate. So, unang-una ay ang ating temperature. So, commonly, alam na naman natin ang temperature. It is the measurement of the hotness and coldness that can be measured by the thermometer. The unit of measurement used are Celsius, Fahrenheit, and Kelvin. So, commonly sa atin dito sa Pilipinas at sa mga nagbabarko or seafarers, ginagamit ay degree Celsius. So, Fahrenheit, commonly ginagamit yan sa United States and sa mga flagships maaari na under ng US. Degree Kelvin, so hindi pa naman ako nakaka-encounter ng uh, country or company or barko na gumamit ng degree Kelvin. So temperature is the biggest factor in determining the weather condition because it influences or controls or other elements of weather such as cloud formation, precipitation, water vapor presence or the humidity, and atmospheric pressure. So kaya nga kanina diniscuss natin yung sa horizontal and vertical heat distribution. So yan yun. Mapasok dyan yun. Then lastly, normally for ships operations, surface air and sea temperature are observed by the mariners on board using different installed instruments. A hygrometer or psychometer housed in a Stevenson screen, which is installed at side of the bridge, is a combination of wet and dry bulb thermometers. Siyempre, yan natin tinitingnan, maaari kung meron mang mamumuong high pressure or low pressure sa ating lugar. Then yung ating nabanggit ng Stevenson screen, yung example kanina. So, itong thermometer nandito sa gilid, yan yung inilalagay. Ito yung hygrometer or much cold psychometer. So, kahit alin dyan yung gamitin nyo on board. So, itong psychometer din ito, din ito sa loob ng bridge, sa engine control room, sa galley, at saka sa mess hall. So, kaya nakalagay din yan doon para malaman din natin kung tama ba or accurate yung humidity content sa loob ng ating mga akomodasyon. So, kaya kailangan lang din natin i-check kung gumagana at tama ba ang reading lagi sa ating mga psychometer. So, syempre sa wet bulb, checkin natin may laman pa ba ang tubig yung ating para sa wet bulb. And titingnan natin yung mercury niyan kung hindi pa basag-basag or putol-putol. So next is the humidity. So humidity has a significant effect on weather. The presence of water in the air indicates the probability of rain, dew, or fog. The atmosphere that contains moisture or water vapor transports energy and prevents the heat from escaping in the Earth's surface. The trapped heat will cause the surface water to evaporate, then condense to form clouds, followed by rain or precipitation. So, yan yung binabantayan natin. Kung mataas ang humidity content, so merong possibility na rain, dew, or fog. So, syempre, especially fog. Nakita naman natin yung fog kapag naghalo yung lamig at saka init. Diba? Then, the mariners use an instrument to predict weather conditions, a hygrometer to calculate relative humidity in an area, and the difference in the wet and dry bulb thermometers is calculated and matched to the relative humidity table. So, yung relative humidity table ay ito. we have here the relative humidity table. So, unang-una, i-read muna natin ang dry and wet bulb sa ating psychometer. So, kapag nakuha nyo na yon, proceed agad kayo dito sa dry bulb temperature dito sa portion left. So, for example, ang ating reading ay 24. Then, the difference between the dry bulb and wet bulb, kukunin nyo rin, is 7, for example. Then, pagtatagpuin nyo lang yung dalawa kung saan sila mag-meet. So, yun yung relative humidity percentage. Okay, so ito namang relative humidity table na ito ay provided na sa ating bridge. So, madaling-madali nyo na siyang makikita doon. Okay, kalimitan naka-post na yan sa may plotting table. Then next, we have atmospheric pressure. So, the Earth's atmosphere contains huge amount of gases circulating on its surface. The layered air particles that are present at a certain area are applying pressure on the surface below it. The air pressure is caused by the different mass of air that is pulled down by the gravity of the Earth as it becomes weight exert to the Earth's surface. Atmospheric pressure is affected by altitude, temperature, and water vapor concentration. Mariners use barometer to measure the atmospheric pressure, which is normally 1.01325 bars in metric system. In general, bad weather signifies low atmospheric pressure, while good weather tells high atmospheric pressure. The average pressure at mean sea level in the international standard atmosphere is 1013.25 hectopascal. So kapag tumaas pa dyan sa 1013.25, so high pressure na yon. So kapag bumaba, so syempre low pressure yon. So ito na may nire-read lang natin, ito yung nasa bridge. So commonly nire-read tayo or nagre-reading tayo ng ating barometric pressure every hour. No. So sa ating mga navigators at sa watchkeepers, so every hour kumukuha tayo niyan para ma-monitor natin kung ang area ba o nasa lugar ba tayo na low pressure or nasa magandang panahon which is high pressure. So kung continuous yan na bumababa, so may possibility na meron tayong low pressure area or bagyo na tinatahak. Okay? So this is an example of a weather forecast. So ito commonly ang nakukuha natin sa ating weather facts mill. So, kung mapapansin nyo, merong mga letter H and L. So, syempre, kapag H, ibig sabihin high pressure yan or yung area yan ay high pressure. Then L, ang area ito ay low pressure. Okay? Then, itong mga numbers na itong makikita nyo dyan, mga 1032, 1038. So, yan yung barometric reading dyan sa area yan. So, malalaman nyo, kapag mas mababa pa sa 1013.25, so, low pressure yon. Then, kung mas mataas, so, syempre, high pressure. Kagaya nito. So, mas mataas yung reading niya. Okay. Next, we have wind. So, wind is the horizontal movement of air due to air pressure difference. There are different forms of wind that can affect the weather condition of a certain place. The small-scale winds and the large-scale winds. So small-scale winds or local winds, on sunny days, the ground heats up quickly while the sea surface absorbs more heat that results in temperature variation between warm land and cooler sea. As the land heats up on the sunny day, the air becomes warm and less dense, making it to rise. The rising air causes lower pressure over the land, and in contrast, the air over the sea is cooler and denser, creating a higher pressure than inland. The pressure variance makes the air to move from the sea to the land to equalize this difference, producing the sea breeze. Then during the night time, the land will lose heat quickly than the sea surface becomes. The sea surface holds the heat longer. As the land cools, the air above it also cools down, making it denser. The air above the sea now becomes warmer and less dense than the inland. As a result, the wind moves from the land to the sea, creating a land breeze. So, yan yung tinatawag nating sea breeze and land breeze. So, dito tayo sa illustration sa left side. So, itong may A and B. So, for example, ng sea breeze, so yung low pressure or warm air cooling and descending. So, air heated over the land and passing. Then, cooler air over water moving towards the land. So, yan yung sea breeze. So, yung galing dito sa dagat, mapapapunta ngayon sa lupa. Yan ay during um, daytime. Then, during nighttime, so baliktad lang yan. Okay? So, yung warm air dito sa lupa, mapapapunta naman dito sa dagat. Again, and air cooling and descending. Kaya sa gabi, pag kayo nasa beach, mapapansin nyo, medyo malamig yung simoy na hangin na galing sa dagat. So, yun yung mga napapansin natin sa beach. Then, large-scale winds or global wind circulation. So, on the global scale, wind patterns and prevailing winds can be experienced for a period of time. The difference in pressure trends to move the air horizontally or vertically at the Earth's surface, moving from high pressure to low pressure. The wind that is created is mostly responsible to the water changes or weather changes and climate conditions because it moves excess heat around. So directly or indirectly, heat energy is transported from warm regions to cooler regions or away from the Earth's surface. So, kaya nga dito sa Pilipinas, nakakaramdam tayo ng malamig na panahon kasi meron tayong global wind circulation. So, syempre, yung hangin na galing sa northern part ay naitutulak papunta dito sa atin. No? So, malamig na hangin na itutulak dito sa atin kaya nakakaranas din tayo ng malamig na panahon. Then, the Coriolis effect and pressure system. So, due to the Earth's rotation, the air is deflected and does not move directly from high pressure to low pressure. The deflection of wind is called Coriolis effect, causing it to flow mostly around the high and low pressure areas. When there is development of low pressure in the northern hemisphere, the force directs the air from the outside towards the low and deflects to the right, turning it counterclockwise around the system. On the other hand, when the high pressure region is developed, it creates pressure force directed away from the high, causing it to be deflected to the right, producing a clockwise circulation patterns around high pressure regions. So, dito sa northern hemisphere, so ang low pressure ay counterclockwise ang ikot. So, napapansin nyo naman ang mga bagyo natin pag ganyan ang ikot nila or yung circulation nila. And yung hangin or yung pressure ay paloob. Okay? Samantalang ang high pressure naman ay palabas. Palabas ang pressure. Pero ang circulation niya ay clockwise. So, yan. Then, sa southern hemisphere naman, baliktad naman sila. So, parang sa bagyo. Ang bagyo dito sa northern hemisphere ay counterclockwise. Then, pag ang bagyo ay nasa southern hemisphere, clockwise direction. So, we have the wind measurement. So, the wind direction and force is a factor that influences the state of the sea. It is labeled by a wind bars on a weather map. The direction is measured by true compass direction, while the speed is measured by an anemometer expressed in nautical miles per hour or knots and in meters per second. So, these devices are mounted together on top of the ship to allow the free continuous flow of air across them. So, meron tayong equipment na nagre-read ng wind or for wind measurement. So, yan yung tinatawag na anemometer. So, diyan natin mababase kung gaano ba kalakas or kahina yung bugso ng hangin. Then, dito naman sa wind speeds, dito sa illustration sa left, so makikita nyo dito ang different symbols at ang katumbas niyang speed from knots or miles per hour. So kapag nag-print kayo sa weather facsimile din ng uh, wind measurement or uh, wind directions sa inyong area, so mapapansin nyo dyan merong mga ganito, yung pabilog na ganyan, dalawang bilog. So ibig sabihin niya calm. Calm or halos or walang hangin dun sa lugar na yon. Then pag nagkameron niya ng guhit, so 1 to 2 knots lang yung hangin. Then kapag nagkameron ng konting buntot, so 3 to 7. So pinaka madaling tandaan sa ganyan, so once na merong maliit na buntot na, so i-consider niya yun as 5 knots. Then kapag nabuo, 10 knots. So kapag isang buo at isang kalahating buntot, so 15 knots. So kada isang sungot na ganitong maliit, or yung buntot niya, i-consider niya na as 5 knots. Okay? Then pag umabot na naman kayo sa 50, so triangle na siya. Okay? Then kapag 55 na siya, then balik tayo sa isang maliit na linya kasama ng triangle. Okay? So 55 to and so on and so on. So ito yung isa sa mga illustration ng wind measurement. So, kagaya ng mga ito, so ibig sabihin 15 knots na to, ang direction ng hangin ay kung saan yung itinuturo niyang ito. So, papunta dyan yung hangin. So, ito ay 10, 20, 30, 40. 40 knots, papunta dito ang hangin. Okay? So, we have here the Beaufort scale. So, ito ay isa sa mga commonly na ginagamit din ng mga seafarers on board at pagre-record sa ating logbook, lalong-lalo na sa deck department. Hinihingi din to ng ating engine department every end of the watch. So, dito nyo mababase yung appearance of wind effects, wind in knots, or yung katumbas na bilis or lakas ng hangin, and force or yung bugso ng hangin. Then, the classification. So, iyan ay napapansin sa ating seawater, yung mga alon or swell. So, kapag zero, so syempre calm. So, sea-like mirror yan. So, dito tayo sa on the water. So, itong on land, so pwedeng hindi nyo nang pansinin kasi ito naman ay dito na sa lupa. So, focus lang tayo on land as a navigator. So, zero force. So, wind in knots less than 1 knot. So, calm. So, sea surface smooth or and mirror-like. So, halos patag na patag yung ating dagat. So, sa pagtaas ng wind force, so syempre sa paglakas ng bugso ng hangin. So, dito nyo na mapapansin kung gaano katataas yan, gaano kataas yung wave or yung alon. So, commonly dito naman tayo sa 7. So, kapag ang pwersa na ay 7, so, ang wind speed na ay naglalaro na sa 28 to 33 knots. So, malakas na yan. So, hindi na pwedeng lumabas ng barko o ng kubyerta. Bawal na rin magtrabaho sa kubyerta kasi delikado baka ma-wash out ang crew. So, maaari kasing sumampa ang alon sa ating deck at ma-wash out or madala ang ating crew. So, yung kalakasan din ng hangin, baka mag-cause pa yan ng man overboard. So, napakahirap yan. Then, ang ating engine team ay naka-standby na rin sa engine room kasi nagko-consider ito as critical condition. So, hindi na may ibig sabihin ng critical condition ay critical na ang lagay ng ating barko, no? So, ito ay parang measurement lang to prepare certain actions para maiwasan magkameron ng aberya or problema. So, Beaufort scale is an empirical measurement for describing wind speed based mainly on the observed sea condition. So, next, let's proceed to clouds. So, clouds are visible mass of condensed water vapor suspended in the atmosphere above the Earth's surface. There are different kinds of clouds, but they are usually classified depending on the height or high clouds, middle clouds, or low clouds. So, ito, alam ko naman, or siguro naman natatandaan nyo pa yung mga zero cumulus, alto stratus, stratus cumulus, cumulonimbus. So, yan. So, we have precipitations. So, is any form of deposit on the Earth's surface that falls because of gravity. It can be in the form of drizzle, rain, snow, hail, or sleet. Some factors that affect may amount of precipitation are location, altitude, topography, temperature, and wind and ocean currents. So, ito depende sa lugar kung ano yung babagsak sa inyong surface. So, kagaya dito sa tropic zone, so commonly rain. So, may mga pagkakataon na hail, kasi yan ay doon sa disturbance sa taas. Then sa mga malalamig naman na lugar, so dyan papasok yung snow and sleet at kahit ang hail. So we have our next topic, which is development of storm. So we have our technical terms muna ulit. So pressure gradient, so it indicates the direction and change of the atmospheric pressure in a certain area. Then riptide, strong sea currents formed by a strong wind that pushes the water towards the shore. And storm surge, the fast uprising of sea level due to strong winds that pushes the water to the coast and the suction created by the low pressure. Then isobar, line that connects the points of the same atmospheric pressure. So yung isobar na yan yung mapapansin yung parang nakapalibot dun sa area kung saan may barometric pressure reading. So kung mapapansin nyo dun sa mapa, yung mga 10, 25, tapos parang may bilog, or parang may boundary, so yun yung isobar. So we have a storm. So storms are very destructive weather phenomena and considers one of the most powerful natural hazard to people. So hindi lang naman siya for the people. Kahit ito ay sa ating as seafarers ay talagang kalaban ng seafarers at ng ating barko. So if a ship is caught in the area of the storm, it might cause partial and complete destruction to the ship, cargo loss, and delays that prompts huge amount of money. For these reasons, mariners must be equipped with the knowledge on how these turbulence are formed. So, syempre kapag kayo naka-encounter ng bagyo, so napakalaking epekto niyan sa ating barko, sa safety ng ating barko, sa safety ng ating kargamento, kaya yung mga container ships minsan tumatagilid or nalalaglagan ng cargo container, and syempre nade-delay yung ating biyahe. Kaya nalulugi si kumpanya sa si ating barko kasi kagaya na lang sa container vessels, may hinahabol tayong schedule. Kapag tayo nade-delay, yung kinikita sana ng ating company ay nababawasan sa ating charterer. The tropical revolving storm is the maritime term for tropical cyclone. So a tropical cyclone is used by the meteorologists to describe a rotating organized system of clouds and thunderstorms that occurs in tropical and subtropical waters and has a close low-level circulation. So we have tropical cyclones. So depende yan or depende ang tawag sa bagyo kung saan lugar naroon kayo. So we have hurricanes. So hurricanes are called for tropical cyclones on North Atlantic Ocean and eastern and western parts of the Northern Pacific Ocean. Then we have the cyclone. So cyclone naman ang tawag sa bagyo kapag nasa Southwestern Pacific Ocean, Southwestern and Southeastern Indian Ocean, and Northern Indian Ocean or the Arabian Sea and Bay of Bengal. Then we have the typhoon, which is dito sa atin, Northwestern Pacific. Tropical cyclone formation. So the development of the tropical cyclone requires environmental condition called cyclogenesis. It occurs mostly between 5 degrees to 20 degrees north or south, wherein the atmospheric low pressure system or the tropical disturbance is created in the ITCZ. It is also influenced by the Coriolis effect. If Coriolis effect is too weak to cause a rotation between 5 degrees north or south and the equator, a tropical cyclone will not form in this area. So kaya nga, di ba, pag may news or nakikinig tayo ng balita sa weather forecast, may mga sinasabing may posibilidad na hindi maging bagyo ang binabantayang low pressure. So yun yun. Kung medyo mahina yung formation ng ating rotation dun sa area yun. So when a rotating thunderstorm passes over warm water, the convection process and rainfall are enhanced. After summer or dry season, cyclones are normally developing because the sea has not yet cooled off. The observed summertime heat has not totally related by water due to its properties. Thus, the surface temperature is warmest in this time of the year. So, siyempre, ang ating dagat, mainit-init pa, tapos nagbabago na yung season. So, naghahalo, kaya nagkakameron tayo ng thunderstorms. So, mamaya meron tayong illustration para dyan. So, as the warm air rises, less air is left near the surface of the water, causing lower pressure. Meanwhile, the higher air pressure that moves below becomes warm and moist. This warm, moist air cools down, forming clouds. This process is continuously fed by the heat of the ocean and water vapor, making faster winds and swirls and more clouds. Thus, stronger and bigger wind and cloud formations create tropical depression. So, ito yung ating tropical cyclone formation. So, syempre, kapag disturbance, pag naghalo na si low and high pressure or yung mainit at lamig na hangin. So, yan. Then next, we have depression. So, mamumuuna or babagsak na yung ating barometric pressure dun sa area yon. Then, the tropical storm. So, yan. Umuuna hanggang sa maging hurricane na yan at naganap ng bagyo. So, itong sa tropical storm na to, or depression, yan yung low pressure area. Then, the tropical storm and hurricane, yan yung bagyo. So, decay. So, when a tropical cyclone crosses over the land and moves a higher latitudes with lesser water surface temperature, it begins to reduce its strength. The lack of warm sea surface weakens a tropical cyclone, thus cause a decay. So kaya napapansin natin kapag ang bagyo ay hindi pa naglalandfall, kalimitan lumalakas ng lumalakas yung kanyang bugso. So yung kanyang hangin at saka yung kanyang rainfall. So once na yan ay naglandfall na, so maaaring humina na yan ng humina hanggang sa mawala na si bagyo. So, once na bumalik na uli yan sa dagat, so maaaring may posibilidad ulit na lumakas ulit siya. Then, kapag pataas na yan ng pataas, so maaaring humina siya due to the absence or lack of warm sea surface. So, syempre, kapag, di ba pag sinasabing malamig ang panahon or malamig yung hangin, kagaya dito sa atin ngayon, habagat, na itutulak niya or nailalayo niya or naitataboy yung low pressure area, hindi natutuloy or hindi namumuo. Then, storm characteristics and structures. A fully developed tropical cyclone has an average diameter of 300 nautical miles or more, average height of 15 nautical miles, and average atmospheric pressure of 960 millibars at mean sea level with a very steep pressure gradient. So, it consists of vortex, or an eye, or yung mata ng bagyo, about 20 to 40 nautical miles in diameter, which is the center of the system. It is generally free of clouds as within the air subsides the warm adiabatically, resulting in a relative calm environment. The eye wall, or the ring, or a ring of cumulonimbus clouds formed due to ascending air, is the immediate area around the eye that experiences the most adverse and violent activity. Yan yung mga heaviest rainfall and strongest wind. So, the rain bands are areas with heavy convective showers spiraling inward towards the center. So, kapag kapag napapansin nyo na ang bagyo kulari tumama sa inyo yung mata o yung vortex na sinasabi, so, kapag palapit na palapit sa inyo yung mata, so palakas ng palakas yung bugso ng hangin at saka lakas ng ulan. Then kapag nasa mata na ng bagyo yung area o yung lugar nyo, so parang gaganda ng konti ang panahon. So maya-maya, mapapansin nyo biglang lalakas na naman si ulan at saka si hangin. So, ibig sabihin, sa inyong area mismo, dumaan yung bagyo or yung mata ng bagyo. So, ito ang ating illustration. So, we have the eye. So, syempre, kita nyo naman, bakanting-bakante. Kaya masasabi talagang kung saan gumanda ang panahon. So, may mga hangin naman, pero humina. Then, itong eye wall, so, mapapansin nyo naman gano'ng kakapal yung ulap sa kanya. Okay? So, yan. So, makita nyo rin naman dito sa top view, kita nyo clear na clear yung gitna. So, yan yung eye or yung vortex. Then, makapal yung paligid ng ating eye wall. So, ship's action in avoiding a storm. Unang-una dapat malaman natin at maunawaan natin yung Buys-Ballot law. So, si Christophorus Henricus Didericus Buys-Ballot was a Dutch chemist and meteorologist after whom Buys-Ballot's law and the Buys-Ballot table are named. So, Buys-Ballot's law are also called Baric wind law or may be expressed as follows. So, ito yung dapat yung matandaan na in the northern hemisphere, if a person stands with his back to the wind, the atmospheric pressure is low to the left, high to the right, and is reversed in the southern hemisphere. So, ibig sabihin, kapag kayo ay gusto nyong malaman kung nasa inyong high pressure and low pressure dun sa area nyo, so kung kayo ay nasa northern hemisphere, so tatalikuran nyo ang bugso ng hangin, pakikiramdaman nyo. Then, kapag naramdaman nyo na yung hangin, kung sino yung nasa left side nyo, or yung left side nyo, yan ang direction kung nasaan ang low pressure area. Then, yung nasa right side nyo, yan yung portion kung nasaan ang high pressure area. So, yun naman ay kabaliktaran sa southern hemisphere. So, kapag tinalikuran nyo ang hangin, ang nasa right side nyo ang low pressure area at ang nasa left side nyo ang high pressure area. Yun ay sa southern hemisphere. So, pwede namang hindi nyo talikuran. So, pwedeng sa harap nyo na mismo o harapin nyo mismo yung hangin. So, ang mangyayari lang sa northern hemisphere, pag hinarap nyo yung hangin, so nasa right nyo yung low pressure at nasa left nyo yung high pressure. So, reverse naman sa southern hemisphere, kapag hinarap nyo yung hangin sa southern hemisphere, so yung nasa right nyo, ang high pressure, at ang nasa left nyo, ang low pressure. Ganun lang kasimple. So, signs of developing a storm. So, swell, unang-una, it depends on the extent of open ocean. So, it becomes prominent with long wavelengths and low wave height due to the strong constant winds and blowing within the area. It can observe at about 600 nautical miles from the center of the storm. So, syempre, kapag nakita yung mataas na yung alon, ayan, ibig sabihin, maaaring may disturbance or low pressure area sa lugar na yun. Then we have the sky. So clouds become thicker, denser, and darker with a rapid increase of wind speed and gusting rainfalls as the storm moves closer around 100 nautical miles or less. So, syempre mapapansin nyo ang langit, kumakapal, dumidilim. So, yan. Then, ang pinaka-the best na gawin ay i-observe ang atmospheric pressure. So, yan ay pagre-reading sa barometer. So normally, a significant decrease from the mean pressure indicates the approach of tropical cyclone. The barometric pressure starts as slow fall and becomes more gradual. Then goes steady fall as the storm approaches. So kapag ay pa-approach sa low pressure area o sa may bagyo, so mapapansin nyo sa reading nyo sa barometer nyo, bumabagsak. So once na nag-steady na yan, so maaaring nandun na kayo sa area kung saan naroroon ang low pressure area o yung bagyo. Then kapag napansin nyo, tumataas na ulit yan, ibig sabihin lumalayo na kayo or lumalayo na si bagyo sa inyong position. So we have another is wind. So as the atmospheric pressure falls, the strength of the wind also increases with frequent gustiness. The increase in wind speed and the change of its direction are the best indications or indicators of an approaching storm. So, yan ang laging basehan natin, ulan at hangin. Kapag malakas ng hangin, so parang paparating na ang bagyo. So, movement of the storm. So, yung mga kulay orange, yan yung areas in which tropical storms typically form. So, dyan malimit na mumuo ang mga bagyo. So, yung mga arrows, white arrows, ay typical path of the storm. So, di ba yan yung malimit na dinadaanan ng bagyo. So, yung mga arrows na yan ay by season. Okay, so hindi pwedeng, lari ay gusto kong, or yung bagyo, sasabihin, gusto kong dumaan dito ang bagyo. Or dito sa isa. We need a marker. Lari, sasabihin, dito dadaan ang bagyong yan. Okay, hindi, dito. So, hindi. So, kaya napipredict ng ating mga meteorologists kung saan dadaan ng bagyo, depende yan sa season. So, for example, during May to June or June to July, dito ang daan ng bagyo. So, dito, to exactly explain it better, so dito sa mga areang ito, basta pataas yan, commonly, yan ay Burr months. So, kapag papunta dito, yan ay June to July. Then, kapag dito, naman ang daan, so, commonly yan ay nasa mga August to September. So, yeah. So, depende yan sa season. So, dito sa iba, so, ganun din yan. So, we have navigable and dangerous semicircle. So, in northern hemisphere, the region to the right of the storm towards the direction of its track is called the dangerous semicircle because of faster wind speed due to the pressure gradient amplified by the forward motion of the storm, and the wind circulation will force the vessel into the path of the storm. On the other hand, the region of the left of the storm track or the navigable semicircle is less dangerous as the wind is decreased by the forward motion of the storm and the wind circulation will force the vessel away from the path of the storm. So kaya mapapansin natin dito sa illustration, sa left, dangerous semicircle and navigable semicircle. So kaya dangerous to kasi dito kung saan yung parang kinakain ni bagyo or kumukuha si bagyo ng puwersa ng hangin. So, kung kayo ay naririto, so makakasama kayo sa kanya. So, while dito sa navigable semicircle, so ito yung kung saan yung tinatapon na niya yung bugso. So, kung saan ilalayo na niya kayo. So, yung bugso ng hangin galing dito sa right portion, so itutula kayo papalayo na ng bagyo. So, kaya yan ang safe or navigable semicircle. So, maneuvering and actions to avoid the storm center. So, we have area of the storm. Kapag kayo ay nasa dangerous semicircle, ship action in northern hemisphere, place the wind on the ship's starboard bow, altering the course to starboard as the wind veers and make as much headway as possible. If necessary, heave to the or to with the head to the sea. So, ship action in southern hemisphere, place the wind on the ship's port bow. Then altering course to port as the wind backs and make much headway as possible. So if necessary, heave to with the head to the sea. Kung kayo naman ay nasa navigable semicircle, so place the wind on the ship's starboard quarter, altering course to port as the wind backs and makes much headways as possible. If necessary, heave to with the stern to the sea. This southern hemisphere, place the wind on the ship's port quarter, altering course to starboard as the wind veers and make much headway as possible. So, if necessary, heave to with the stern to the sea. So, on the storm track, ahead of center, bring the wind on the starboard quarter, hold course, and make much headway as possible. When with navigable semicircle, maneuver as required above. So, ito na ang susundin nyo. So, while sa southern hemisphere, Bring the wind almost astern, hold course, and make much headway as possible. When within the navigable semicircle, maneuver as required above. So on the storm track behind center, take appropriate and best practicable course keeping in mind the tendency of the storm to curve in northwesterly direction. And sa southern hemisphere, take appropriate and best practicable course keeping in mind the tendency of the storm to curve in southeasterly direction.